Hi, and welcome to day 3 of evaluating trigonometric functions. First, please pause the video and do these 3 warm-up problems to review what we did in day 2. Please pause now. Okay, so what you should have done on number 1 is you should have drawn a graph. Oops, sorry about that. You should have drawn a graph, and 225 degrees is in quadrant 3. So we always draw it in standard position back to the x-axis, and we would see that that would be a 45 degree angle, because 45 degrees is 225 degrees is 45 degrees more than 180. So we can realize that this is then a 45, 45, 90 right triangle. So we label our triangle as x, x, and x squared of 2. The sine is always equal to the opposite divided by the hypotenuse. So this would be the opposite. The hypotenuse is always our longest side, which is x squared of 2. So here we can see that the x's cancel out. I'd be left with 1 over the square root of 2. We rationalize the denominator, and I end up with the square root of 2 over 2. Not to forget, at the very end, we double check with all students take calculus. Here the tangent is positive, so that means that the sine would be negative. So our final answer is negative square root of 2 over 2. On the second one, we started off the same way. So we draw a graph. 11 pi over 6. That is almost 2 pi. In fact, it's 1/6 less than 2 pi. So this would be pi over 6 radians, which is the same as 30 degrees. Now, as this is still kind of new to some of you, you may find it helpful to take 11 pi over 6 times by 180 degrees over pi and simplify that if you need to. And you would end up with 330 degrees, which would leave us with 30 degrees below 360. So we label our sides of our 30, 60, 90 triangle. We label the side opposite of our 30 degrees with x, opposite of our 90 degrees, or our hypotenuse, with 2x, and our remaining leg with x times the square root of 3. Next, we know that we are evaluating for the cosine. Cosine is equal to adjacent, which is x times the square root of 3, over the hypotenuse, which is 2x. The x's will always cancel out, so we're left with the square root of 3 over 2. Once again, we remember at the end to double check all students take calculus, and down here in quadrant 4 the cosine is positive, so our answer is just the square root of 3 over 2. For our last one, we want to do the cotangent of negative pi over 3. So we get a little bit more complicated here at the end, but we draw our graph. Negative pi over 3 is the same as negative 60 degrees. So that's going clockwise 60 degrees. So we put a 60 degree angle inside the triangle next to the x-axis, and we start labeling our triangle. Opposite of the 30 degrees is x, our hypotenuse is 2x, and our other leg is x times the square root of 3. Now the tangent of that angle would be equal to opposite over adjacent, so that would be x square root of 3 over x. So the cotangent would be the reciprocal of that function, or x over x squared root of 3. Again, the x's cancel out. We're left with 1 over the square root of 3, so we rationalize the denominator by multiplying top and bottom by the square root of 3, and we end up with the square root of 3 over 3. Double check all students take calculus. Down here the cosine is positive. That makes this answer negative, and we are done with the warm-up. So in today's lesson, we are going to be finding the other 5 trig functions given some variance of information. The first one here says that the tangent of theta is equal to negative 5/3. So the first thing I double check is where all students take calculus. Since the tangent is negative 5/3, the negative is the important thing here. I know that that cannot happen in quadrants 1 or 3 because the tangent is positive in those quadrants. It could happen in either one of the other two quadrants, so I just draw a random right triangle down here into quadrants 2 and 4. The tangent is equal to opposite over adjacent, so I'm going to label these as 5 and 3, and likewise 5 and 3 down here in the other missing quadrants. We now have two sides of a right triangle here. Sorry, that's not a very good right triangle. So we could use Pythagorean theorem. 3 squared plus 5 squared equals c squared. And we'd end up with 9 plus 25 is 34. So c would be the square root of 34. We do a factor tree that doesn't simplify, so we leave it as the square root of 34. And that's true for both of these triangles. So now we are ready to evaluate the other 5 trig functions. So the sine of theta would equal opposite over hypotenuse. So we'd have 5 over the square root of 34, which when we rationalize would become 5 square root of 34 over 34. The cosine of theta would be adjacent over hypotenuse. So we'd have 3 over the square root of 34, which would then become 3 square root of 34 over 34. The tangent is already done for us, so now we are ready for the cosecant. Remember, the cosecant goes with the sine, so that would be the hypotenuse over the opposite, so that's the square root of 34 over 5. Notice if you had tried to take the reciprocal of the sine function, you'd have 34 over 5 square root of 34. You could do it that way, but you still need to rationalize the denominator and simplify the fraction, which would ultimately get you back to the square root of 34 over 5. Next, we have the secant of theta. Whoops, I missed the c, sorry about that. So the secant of theta is the reciprocal of the cosine function, so that's the hypotenuse over the adjacent, so that's the square root of 34 over 3. And our last one is the cotangent function, which is the easiest of all of them because they gave me the tangent up here, so the cotangent is negative 3/5. Which reminds you at the very end that you need to go back and check your signs for all of them. So here in quadrant 2, for this triangle here, the sign would be positive, but the other ones would be negative. Oops, sorry, that one would be positive, this one would be negative. Down here in quadrant 4, though, that's where the cosine is positive. So at that point, this one would be positive, but this one would be negative. So we need to be able to look at how these would be either positive or negative depending on which quadrant it's in. This will be a whole lot easier when they give us more information, like here on this next problem. So here for the next problem, they say given that the cosine of theta is equal to 3/4. The main thing to notice right now is that is a positive 3/4. So we're looking where all students take calculus, where the cosine is positive. And we see that that could not happen in quadrants 2 or 3. So our only choices from that information is that it occurs in quadrants 1 or 4. Then they give us a little bit more information. They tell us that the cotangent of theta is greater than 0. That's another way of saying that the cotangent is positive. Remembering that cotangent has the same sign as tangent, we see that tangent is only positive in quadrants 1 and 3. It is not positive in quadrants 2 or 4. So the only possible quadrant that we could draw a triangle is quadrant 1. So we do that. We draw a right triangle here in quadrant 1, going back down to the x-axis. And now I concentrate on the 3/4. It tells me that the cosine is equal to 3/4. Cosine is adjacent over hypotenuse, so I label it as 3 and 4. And then I do a little Pythagorean theorem work. So I do 3 squared plus x squared equals 4 squared. So we get 9 plus x squared equals 16. So x squared is 7, so that means that x is the square root of 7. So I'm going to label that as the square root of 7. So now it says find all of the trigonometric ratios. So the sine of theta would equal the opposite over hypotenuse, so that's the square root of 7 over 4. Remembering here in quadrant 1, everything's positive, so I don't have to worry about anything being negative. The cosine they already gave us. The tangent of theta is opposite over adjacent, so that's the square root of 7 over 3. The cosecant of theta is the reciprocal of the sine function, so it's hypotenuse over opposite, so that's 4 over the square root of 7, which becomes 4 square root of 7 over 7. The secant of theta is the reciprocal of the cosine, so I simply take the reciprocal of that function there and I would get 4 over 3, or in other words, it's hypotenuse over adjacent. And then the last one is the cotangent of theta. Cotangent is the reciprocal of the tangent function, so it's adjacent over opposite, so that's 3 over the square root of 7, which becomes 3 square root of 7 over 7. We've got one last example here. It says given that the secant of theta is equal to -2, so all I'm going to worry about here is the secant is the same sign as the cosine function, so it's telling me that the cosine function is negative. So when we look at all students take calculus, I know that it cannot occur in quadrant 1 because that's where cosine is positive, or in quadrant 4. The other bit of information it gives us is that theta falls between 0 and pi. Remember, this is 0, pi over 2, pi. This is 3 pi over 2 down here, and then 2 pi here. So we're saying that theta falls somewhere in this region. So it cannot occur down here. So it cannot occur down here, so it must be in quadrant 2. So I draw a right triangle here in quadrant 2. So technically my theta would be down here. And now we go back to the secant of theta equals -2. That's the same as saying the cosine of theta equals -1/2. So now I can label my right triangle. The adjacent is 1, the hypotenuse is 2. A lot of students ask me, well, can I include the negative on the 1? You can, and that's fine. I would just caution you to never put the negative sign on the hypotenuse, to always be careful with that, to put the negative sign on either your x-axis or your y-axis value. And for the most part, that will take care of worrying about the positive or negative of all of your trig functions. So now we do some Pythagorean theorem here. So 1 squared plus y squared equals 2 squared. So y squared would equal 3. So y is equal to the square root of 3. So now we are ready to write down the sine of theta. Sine is equal to opposite over hypotenuse, so we'd end up with the square root of 3 over 2. Remembering here that the sine is positive. Cosine we have already found. Tangent of theta is opposite over adjacent, so that's just the square root of 3. We don't have to write that as a fraction since it's over 1. Remember that it's negative, so we put a little negative sign there. The cosecant is the reciprocal of the sine function, so it's hypotenuse over opposite, so we'd end up with 2 over the square root of 3, which becomes 2 square root of 3 over 3. And it's positive just like the sine function is. We've already found, or we were given the secant function, so the last one we need to find is the cotangent of theta. The cotangent of theta is 1 over the tangent, so that is adjacent over hypotenuse, so we'd end up with 1 over the square root of 3, or in other words, the square root of 3 over 3, and that needs to be negative as well. That is the end of the video. Thank you for your time.